Hello friends, today we are going to have a look on the look and the see look algorithm of disk scheduling. The look and the see look algorithm, I can say that they are the versions of the scan and the see scan algorithm. What happens over here is the arms only goes as far as the last request in each direction are there. Means they don't go up till the end, they go up till the last request in each direction, then reverses the direction immediately without first going all the way to the end of the disk. Now it's very simple how it can is we just go back to the scan part. What we can see over here, the head start is at 53 and we choose a direction that is in decreasing order. So from 53 we move on to 37, then from 37 we move on to 14, and from 14 we move on to 0. But this doesn't happen in look. In look what will happen is it will not go all the way to end of the cylinders or the tracks. It will immediately change its direction from 40 to 65. It will, what it says, it will go as far as the last request in each direction. So in the decreasing direction the last request is 14. There are no other requests after 14 in the decreasing direction. So it will take a reverse from 14 and moves towards 65, 67, 98, 122 and so on. So this is the scan version, that is the look. If you want to see for the C scan, or that is C look if you want to see. So what you can see over here, 53 is moving till the end, then as soon as it reaches the end it moves back to the 0 and it again start fulfilling the request. But if I go for the C look, what happens? We'll see. 53 is starting, then 65, then 67, then 98, then 122, 124, 183. Now here it is the point to note that from 183 it is not moving to 199. From here itself, here after 183 there is no request to be fulfilled. Again I'll repeat the sentence. It will move as far as it reaches the last request in each direction. So 183 is the last request in the increasing direction. As soon as it reaches the last request, it will reverse its direction and it will move not to 0. It will not move to 0. It will move to the last request in the decreasing direction. So the last request in the increasing direction or in the descending order is 183, and the last request in the ascending order, that is the as we go down, the last request is 14. So from the highest request it will come to the lowest request, it will fulfill it and it will move forward to 37. So this is what will happen. Now you can see 183 is the last request to be fulfilled. In the reverse direction you can see 14 is the last request to be fulfilled, and again in the reverse direction you can see 37 is the last request to be fulfilled. So in this way we say that we have scan and C scan. Look and see look are the versions of scan and the C scan. And let's have a look on next point is what? Let's have a look on the disk scheduling algorithms or the selecting of disk scheduling algorithms. The first point is SSTF is the common and has a natural appeal. So that is the shortest time, serving the shortest time first. Then scan and C scan perform better for systems that places a heavy load on the disk. Okay, if you're normally using anything, if your load is normal, then you can go for SSTF. If your load is a heavy one, you can go for scan and C scan. Now the performance depends on the number and types of requests. Of course, these are the basic dependencies, that what are the number of your requests and what are the types of your request. Then the next point is dependency is what? A request for the disk service can be influenced by the file allocation methods. Of course, the file allocation methods play a very important role. Then the disk scheduling algorithms should be written as a separate module for the operating systems. allowing it to be replaced with a different algorithm if necessary. Okay, this can be, we need to keep things flexible. We need to have things flexible so that we can have the change of disk scheduling algorithm whenever we want. If you don't keep it separate, and if you if you combine with or compose it with other algorithms and other of your file documents, other of your codings, then that is difficult for you to replace any algorithms. It's just to have flexibility in your disk scheduling algorithms, you need to have a separate module for it so that you can replace that module whenever you want. Next is either SSTF or look is a reasonable choice for the default algorithms. Yes, of course, we cannot go for scan uh, as a first choice always. Why? Because scan, they need to, the head needs to move from the head point to the end, in one single direction. But look says what, that you do not need to go at the very end of the cylinders or the tracks. You just need to go for the last request in each directions. That this is going to save much of your sequence in that way. So this is all. Thank you all, and I hope you understood all the disk scheduling algorithms. Thank you.